Got the whole photo.
Guys, we're looking at 3 merit questions from 2011 today. So off we go. So today's first question is from Algebra in 2011. So this was a merit question. So what you're asked to do is you're asked to find out x in terms of p. So the first thing you really want to do is you want to get rid of those square root signs. And the way you're going to get rid of it is by squaring everything. Okay? If we do this, we get p squared. Square root of x minus 3 squared will become x minus 3, and that's equal to 16, because 4 squared is 16, and then square root of x squared is just x. So expand this out, you've got p squared x minus 3p squared equals 16x. Rearrange, so you got p squared x minus 16x equals 3p squared. Now take out x as a common factor, and you have p squared minus 16 equals 3p squared. And from this point, it's just a matter of putting x is equal to 3p squared over p squared minus 16. Okay? Now, I know I'm looking at the answer schedule, and one of the things that they're actually mentioning is you must actually write down that p can't be positive 4 or negative 4. Okay? The reason is it can't be positive or negative 4 is because if you put 4 in this p squared, 4 squared is 16, and 16 minus 16 becomes 0. So this doesn't actually exist. You can't actually have a number divided by 0, and therefore it's going to give you an invalid answer. Now in this schedule that I'm looking at, they're actually saying that it's not required, but at least just get into the habit of just having a look at your questions and answering it completely. Okay? So I think this was a pure merit question. There was no achieved or anything like that. Go.
So to figure out that p can't equal to plus, you make sure that you use a value that would make the bottom thing equal to 0.
Yeah, the denominator equal to 0. You can't have a denominator equal to 0.
Yeah, that's it.
Yep. Is that all right?
So the middle sign is for not equals to.
Yeah, the middle sign, this symbol here,
Yeah.
that basically says it can't equal to plus or minus 4. Okay, should we go to the next one? With this question, I want you guys to have a look at it. I mean, it actually says the sum of two positive numbers is s. All right. So the first thing I'm going to do is I'm going to write sum of two positive numbers. I'm going to have x plus y, and that is equal to s. Does that make sense? X is my first number, y is my second number, and the total equals s. And now they're saying p is their product. Okay, so p can be written as x times y. Is that okay? Now remember, I told you guys in differentiation it's really important that you have all of them in one variable. You can't have like two different variables. So looking at it, I'd have to have a look here, because whoa, arrow's going the wrong way. There we go, better. Because s is equal to x plus y, I can write this as s is equal to, no, I don't want s is equal to, I'm going to put x equal to s minus y. Does that make sense what I've done? Because the total minus the second number would equal the first number. So with that, I could actually rewrite the product formula, because I could have that as, instead of putting it as x, I actually put s minus y and then multiplied by y. Okay? Does that make sense so far? So now what we can do is we could actually write this as product then would equal s multiplied by y minus y squared. Okay? Now they're showing the actual part, the question itself is showing, asking you use differentiation to show that p is a maximum when numbers are equal. So I need to actually differentiate this function, which is p. I need to differentiate it. So p dash in this case is going to be s minus 2y. Is that okay so far? Now when a maximum occurs, what's the gradient equal to? 0. So I'm going to put p dash is equal to 0. Therefore 0 is equal to s minus 2y. When I rearrange this, I'm going to get 2y equals to s. Is that okay so far? And the next part I can do is y equals s divided by 2. Now just looking at this, it's straight away it's telling us that like the total divided by 2. If you do a total divided by 2, you're going to have 2 equal parts, right? Because if you divide a number, you're going to get 2 equal parts. And if s is the total, and if you divide it by 2, you're going to get 2 equal parts. But we're going to prove that. So if we go to x, because y equals s over 2, and I'm looking at this equation, x is equal to s minus y, which means x is equal to s minus s over 2. All right, I got this s over 2 from here because y is equal to s over 2. And if I simplify this, I'm going to get x also as s over 2. Because s minus s over 2 is going to be s over 2. Because look, this is just like 2s over 2, and then 2s minus s is s over 2. And so from here, you guys can see that x and y are the same thing. So you kind of just say, therefore, x is equal to y, which equals s over 2. Questions? So yeah, first step is like getting it all in one term. And then once you get it all in one term, it becomes pretty much straightforward after that. Differentiate equals to 0, solve. The usual jargon. Is that okay? Can we go to the next question? Okay, so with this question, you've asked to find the integral of this. Now, they actually give you a bit of a clue. Use like a suitable substitution may be useful. All right. So this one, you have to use substitution rule. There's no other way of doing this whenever you're dealing with square root symbols. So the first thing I'm going to do is I'm going to put down u equals to 2x plus 1. Okay, that's the very first step. The second step is I'm going to differentiate du dx and find out what dx is. So du dx is equal to 2. That part I differentiate. Straightforward. Now I'm going to rearrange this so that I can write dx equals du over 2. Is that okay so far what I've done? So that's the u part that I've done. The next thing is, so this is, I'm dealing with right now, the purple part is dealing with 2x plus 1 and dx. Now I need to deal with this 2x plus 5. Okay? I need to write 2x plus 5 in terms of u. Now what I could do is, because u equals 2x plus 1, I can write this as u minus 1 equals 2x, and then x is equal, oh, actually now I'll stop here, because I have 2x is equal to u minus 1. What that means is, I could take this 2x and I can substitute it here. Okay? Let me just put an arrow. You can substitute it there. So I can rewrite this whole integral symbol. So I've got 2x plus 5 square root of 2x plus 1 dx. I'm going to start splitting things up. The first thing I'm going to take care of is the 2x. Because I have a 2x there, and that's equal to u minus 1, I'm going to put that as u minus 1. Okay? Nothing's happening to the plus 5. I'm going to leave it as it is. I still have to have the square root symbol, but because 2x plus 1 is u, I'm going to put that as u. Now I need to get rid of the dx, but I've done dx. Dx is here, which is du over 2. So instead of dx, I put that as du over 2. Okay? Still not integrating. I'm still making this equation as simple for me as possible. So simplifying this, I have u plus 4 multiplied by u to the power of half and du over 2. And still not done with it. I'm going to get u to the power of 3 over 2 plus 4u to the power of half du. Now, because it's being divided by 2, I can take it outside, out into the in the front. I could write it as a half. Okay?
Did you get 3 over 2 from?
Because this is u to the power of 1. U to the power of 1 times u to the power of half is 1 plus a half is 3 over 2. Okay? Now I can actually start integrating this. So this would be a half. I've got u to the power of 3 over 2, which is 5 over 2, because 3 over 2 plus 1 is 5 over 2. Divided by 5 over 2 plus 4u 3 over 2 over 3 over 2. Don't forget your plus c somewhere there. And that's what I'm looking at. Does that make sense so far what I've done? So from here, you guys don't need to simplify it. Just replace the u with 2x plus 1. So your final answer would look like this. A half. So instead of u, you have 2x plus 1 to the power of 5 over 2. And this could be written as 5 over 2 plus 4, 2x plus 1, 3 over 2, and 3 over 2 plus c. Okay? When you simplify this, you're going to end up with, because there's a half, all gets cancelled out, you're going to get 2x plus 1 to the power of 5 over 2 over 5 plus 4 over 2x plus 1 to the power of 3 over 2 over 3 and plus c. Yeah, so the c, you don't really, even if it gets divided by half, it's still going to be just c. It's still a constant. So you don't need to worry about like anything with the constants. You can just leave it as the c, almost ignore it, and just leave it as a c at the end. So guys, in terms of grades, merit, all the way here, I think achieved is, let's see, achieved is somewhere here by the looks of it, the integration of u. Yeah, just the integration of u, if you write it as u and integrate it. Okay, any questions on this? Now substitution is the easiest integration, guys, because it nicely works out. Everything works out if you learn how to use substitute, like learn how to substitute things properly. The whole equation should work out real nicely for you. Okay? All right, that's all for today.
When are you giving out those AME books then?
Oh, give a second, mate.